Okay, section 8.7, complex numbers, day 2. So this is again going to be a very quick lesson. Hopefully doing your homework you got used to the idea of using I and dealing with imaginary numbers and things like that. Okay, so I told you previously that we are going to continue on with multiplying complex numbers. And we're going to treat this just like a FOIL problem. Okay, so in number 1, I'm literally multiplying my front, my outers, my inners, and my last. Okay, so I'm multiplying 8 times 2. That's 16. I'm multiplying 8 times I. Okay, that's positive 8i. I'm then multiplying negative 3i times 2. That's negative 6i. So the I doesn't change, right? You just multiply your real numbers together. And then I am going to multiply negative 3i times I, which is negative 3i squared. So again, treat I like a variable. And I'm going to combine my like terms. So I'm going to combine the 18i and the negative 6i. So that's 16 minus 2i, right? The I doesn't change. But now, this negative 3i squared, we know from this last lesson that I squared is going to change because I know that I squared is equal to negative 1 because the square root of negative 1 squared, the radical goes away and I'm left with just negative 1. So this is actually negative 3. Instead of I squared, I'm going to be writing negative 1. So I get 16 minus 2i, and negative 3 times negative 1, that becomes positive 3. So now I have another pair of like terms, so I'm going to add 16 and 3. That becomes 19 minus 2i as my final answer. Okay. In number 2, I want you to notice that I have the same exact 2 terms, but look, one's minus, one's plus. Okay, hopefully you're remembering what that means, right? This is a difference of 2 squares. Now I'm going to do it the long way. Okay, but if you remember the trick, you could also do the trick. So I'll do both. I'm going to do the long way first. So I'm going to do 6 times 6. That's 36, right? So I'm still foiling. 6 times 5i. That's 30i. I'm going to do negative 5i times 6. That's negative 30i. And then negative 5i times 5i, that is negative 25i squared. Okay, well here's some like terms. Just as if this was a 30x minus 30x, it's going to cancel out. If I have 30i minus 30i, those are also going to cancel out. So I have 36 minus 25i squared. Well, again, we know that I squared is also negative 1. Okay, so that becomes 36. Now it's plus 25, right? Negative 1 times negative 25. I'm going to add those two things together, and I get 61 as my final answer. Okay, so again, you can FOIL, or, I like shortcuts. I'm going to do the shortcut in this light purple over here. So remember, the shortcut is you square the first term. Okay, let me erase all this so it's easier to tell. So I'm going to square this first term right here. So I get 36. Then I'm going to square this term. Okay, so that actually becomes 25i squared, right? Because you're squaring the 5 and you're squaring the I. Then we tag subtraction in between. Same exact process for a difference of 2 squares, but now I just have to simplify my answer. Okay, so it's 36 minus 25, and I'm going to replace that negative I with a negative 1. So 36 plus 25, and then we arrive at our same answer of positive 61. Now each way would work. Obviously, I like the shortcut, but if you don't like the shortcut, please feel free to use the long way. Okay, and then finally number 3. Okay, we have our fun perfect square binomial. I'm going to do the shortcut first, and then I'm going to do the long way. Okay, so remember, this is just saying 3 plus 2i times 3 plus 2i, right? And then we could FOIL that out. Or we could square the first. So that becomes 9. Then to get the middle term, it's the same thing. So I'm going to multiply these two together. So I get 6i, and then I'm going to multiply that by 2. So that becomes 12i. Okay, that's double the product. And then I'm going to square the last. So that becomes 4i squared. So the 2 gets squared and the I. Okay, and then I'm going to simplify from there. So I get 9 plus 12i. I'm going to replace that I squared with negative 1. So 9 plus 12i minus 4. You could skip this step if you want, if you already know that I squared is going to become negative 1. Okay, now I'm going to combine the 9 and the negative 4, so I get 5 plus 12i as my final answer. Okay, again, you're squaring the first term, doubling this product right here. Okay, then you're squaring the last and simplify from there. Now, if you don't like that process, I'll do it the long way over here. I'll do it in this green color. Okay, so 3 times 3, that's 9. 3 times 2i, that's 6i. 2i times 3, that's another 6i. 2i times 2i, that's 4i squared. So combine your like terms. Those are those two middle terms right there. That becomes 12i. Remember, the I doesn't become I squared because you're just adding. You're just combining like terms. And this becomes 4 times negative 1. So 9 plus 12i minus 4. Combine your like terms. So I get 5 plus 12i as my final answer. Okay, so it's everything you already know how to do. The only thing that's different is you're dealing with an I instead of any other variable, and you got to change your I squared. Okay? Okay, so right now I want you to pause. I want you to do the U try, and then replay it, check your answer, see if you get the same thing as me. I really hope you guys could hear Millie snoring, by the way, because that's her in my lap right now as I'm teaching this lesson. Okay, so number 1. We do 4 times 5, that's 20, plus 28i, minus 15i, okay, and then minus 21i squared. So I'm going to combine my like terms, so 20 plus 13i, and then that becomes negative 21 times negative 1. So 20 plus 13i, this now becomes positive 21. I have to combine those like terms now, and my final answer is 41 plus 13i. Okay, then in number 2, hopefully you realize this was a difference of 2 squares. Again, same two terms, one's plus, one's minus. I'm going to do the shortcut. If you did the long way, hopefully you end up with the same answer as me. Okay, so I'm going to square this first term. That's 49. And then I'm going to square this term. Remember, you're squaring the 3 and the I, so that becomes 9i squared. Always tag subtraction in the middle. Before you change the I squared or anything like that, it's always going to be subtraction. Okay, then it becomes 49 minus 9 times negative 1, which in turn becomes 49 plus 9. And then I get 58 as my final answer, so no more I. Okay, dividing complex numbers. Okay, so in example 1, I have 9 divided by 2i. Now, we're kind of asking ourselves, how many times can an imaginary number go into a real number? Which is kind of a weird concept to think about. So we're not actually dividing these, we're more simplifying them. Okay, and I'm going to rewrite this as 9 over 2 square root of negative 1. So when we have I in the denominator, it's like having a radical in the denominator. We kind of just talked about this. We can't have a radical in the denominator, right? We have to get rid of that radical. Well, how do I get rid of that radical? I multiply the top and bottom by that radical, right? If I wanted to get rid of the square root of -1, I would multiply by the square root of -1 over the square root of -1. Well, we know what the square root of -1 represents, right? That represents I. So we're going to go back to the fact that we know I squared is equal to -1, right? That gets rid of my radical -1, right? So if I want to get rid of this I'm going to multiply the top and bottom of this fraction by I. So this becomes 9I, and we know that this becomes 2I squared. However, like I just said, I squared is the same thing as -1. So this is 2 times -1, which now becomes 9 over -2. Sorry, 9I over -2. And that is our most simplified answer. And then that's literally it. I can't simplify anymore, but I no longer have a radical in the denominator. And then there we go. So in number 2, same thought process. I need to get rid of that I, which is also representing the square root of -1, right? Well, again, we know that I squared, sorry, this is messy. We know that I squared is equal to -1. So I'm going to multiply the top and bottom by I. So in the numerator, I get 8I over 3I squared, or 3 times -1. Okay, which becomes 8I over -3. I don't care where your negative goes, just as long as you have 1. And I can't simplify, so I'm going to leave my answer as is. Okay, number 3. So this is a little bit different, but it's just like when you had a binomial in your denominator that had a radical in it. Okay, let's think back to how we got rid of that radical. So let's think, how could I get rid of this I? Well, I am going to create a difference of 2 squares. I'm going to multiply by the conjugate. The conjugate is the same 2 terms, but the opposite sign. So when you're creating a difference of 2 squares, you're multiplying by the conjugate of a binomial. Okay, let me actually write that word out. So this is the conjugate. Okay, so when you multiply by the opposite, you're multiplying by the conjugate. Okay, now I'm going to erase that because I need the room to multiply. So remember, what you multiply to the top, you also have to multiply to the bottom. So guess what I have to do in my numerator? I'm going to have to distribute. Let me do that in a different color. So I have 6 times 4, that's 24. I have 6 times 5i, that's 30i. I times 4, that's 4i. I times 5i, that's positive 5i squared. All over. Well, I created a difference of 2 squares. So I'm going to take the shortcut. You can totally FOIL if you want to, but I know that my middle term is going to cancel out. Okay, so I'm going to square the first term, that's 16. I'm going to square the second term, that's 25i squared, and then I'm going to tag subtraction in between. So out of all of this, I'm going to start simplifying and combining my like terms. So in the numerator, I have 30i and 4i, so that's 24 plus 34i. Okay, and then I know that I squared becomes -1, so that's 5 times -1, so that becomes -5 all over 16, and that's -25 times -1. Okay, so I'm going to combine my like terms. So I have a like term here and a like term here. So that becomes 19 plus 34i over 16 plus 25. Okay, so 19 plus 34i over 41. But we want to write this as a complex number. Okay, and to do that, I'm going to separate my real number from my imaginary number. And what I'm going to do is split this up into 19 over 41 plus 34 over 41i. And there we have it. That's my final answer right there. Okay, and I'm going to do the same thing in number 4. Okay, so I'm going to multiply by the conjugate. Again, think to yourself, what would the conjugate be? Well, it's creating a difference of 2 squares. So it's going to be 7 now minus 2i. And multiply the top and bottom by the same thing. Okay, so you're going to have to FOIL. So 6 times 7, that's 42. And then 6 times negative 2i, that's negative 12i. 5i times 7, that's 35i. 5i times negative 2i, that is negative 10i squared. All over. Remember, this is a difference of 2 squares in the denominator, so you could definitely use the shortcut, or you could FOIL and go from there. Again, I'm going to do the shortcut. So I'm going to square the first term, that's 49. Square the second term, that's 4i squared. Again, the 2 and the I get squared, and then you tag subtraction in between. So in the numerator, I'm going to combine my like terms. I get 42, and then 35 minus 12, that's 23i. And then negative 10i squared is the same thing as negative 10 times negative 1. Again, you could do less steps than I'm doing. I'm just kind of writing it out so you could see exactly where all of my numbers are coming from. And this becomes negative 4 times negative 1 because we know I squared equals negative 1. So 42 plus 23i plus 10 all over 49 plus 4. Combine like terms in the numerator, 52 plus 23i over 53. Okay, and then we want to write it as a complex number. So it's going to be 52 over 53 plus 23 over 53i. Okay. All right, last section, raising I to different powers. Okay, so remember, we know I is the square root of negative 1, and we know that I squared is equal to negative 1. So when we start raising I to higher powers, we start catching a pattern. Okay, so once we get into I cubed, I know that it's the same thing as I squared times I, right? Because you add your exponents. So I squared times I is the same thing as I to the third. Well, we know that I squared is negative 1, but negative 1 times anything just becomes the negative that. So I have negative I, or negative square root of negative 1. Okay, if I get into I to the fourth, I know that I squared times, I squared squared, is I to the fourth. That's negative 1 squared, which becomes 1. We keep going round and round into these different patterns. Notice that these are matching up to be the same answers. Okay, so if I go down the line, it goes I, negative 1, negative I, 1. Once you get past 4, it starts repeating the same pattern. So every chunk of 4 for your powers, you're going to repeat the same exact pattern. It's going to go I, negative 1, negative I, 1. Okay, this is very important, these chunks of 4. Okay, that is how we're going to simplify problems like number 1. Okay, so I want to find the powers of I. So that means I want to simplify this as much as I can. What is the most basic power that I could break this up? So literally all you want to do is find the biggest number under 25 that is divisible by 4. Okay, the reason why that is because I want to create some form of I to the fourth power, because I know I to the fourth power is equal to 1. Okay, and that's going to make my job a lot easier knowing that. So I know the biggest number that's divisible by 4 under 25 is 24. Okay, and so I could split up I to the 25th into I to the 24th times I. Okay, and I'm going to use the fact that I to the 4th power is equal to 1 to help me simplify this further. Okay, so I'm going to divide 24 by 4. Okay, obviously that's 6. So I'm going to turn this into I to the 4th power to the 6th power, right? I'm applying the power rule of exponents, right? If you have an exponent outside of parentheses, you can multiply those two together and you'll get I to the 24th. Okay, and then I'm going to keep that I the same. Well, I know from this chart, okay, that I to the 4th is equal to 1. So this is actually also saying 1 to the 6th power times I. Well, I know 1 times itself 6 times is going to be 1, right? 1 to any power is going to be 1. So this is 1 times I, which is just I. So the most simplest form of I to the 25th is going to be the same exact thing as I. So we're essentially trying to find which I out of this chunk of 4 are we getting as our answer, okay? Because as we keep going through these powers, these are all going to end up equaling the same thing. Okay, so in number 2, I need to think of the biggest number under 43 that is divisible by 4. So 42 is not divisible by 4, 41 isn't, but 40 is. So I'm going to put I to the 40th, but I still have 3 left, so this is I to the 3rd. Okay, and then I'm going to turn this into a power of 4. So divide 40 by 4, this becomes I to the 4th to the 10th power, right? Because 40 divided by 4 is 10, and I get I to the 3rd power. Okay, so this becomes 1 to the 10th power times I to the 3rd. So this is equal to 1, and then I want to refer you back to this chart, and I want you to notice that I to the 3rd is equal to negative I. Okay, so I can actually simplify this further because I know I to the 3rd is the same thing as negative I. So my final answer is negative I, because 1 times negative I is just negative I. So this is as simple as we could get. So if you have an exponent under 4, you could simplify that further. Okay, so if we have I to the 1st, we leave it as I. If we have I to the 2nd, we're going to change to negative 1. If we have an I to the 3rd, it's going to be negative I. If I have I to the 4th, it's going to be 1. Okay, so in number 3, this is actually a little bit easier for us because 56 is actually divisible by 4. So if I divide 56 by 4, I'm going to get 14. Well, I know that's the same as 1 to the 14th power, so my final answer is just positive 1. So I didn't even really need to break it up. I just needed to simplify 56 into powers of 4, right? It's I to the 4th 14 times, which is the same thing as 1 14 times, which is just 1. Okay, then number 14. So a number under 18 that's divisible by 4, I know that's 16. So that's I to the 16th power times I to the 2nd. So I'm just breaking up I to the 18th. Okay. Well, I know I to the 16th is the same thing as I to the 4th power to the 4th power, right? I just divide 16 times 4. And then I'm going to refer back to my chart because I have a power less than 4. I'm going to see what that simplifies to. Hopefully we remember without looking at the chart, but I squared is equal to negative 1. So instead of writing I squared, I'm going to write negative 1. This is actually 1 to the 4th power times negative 1, which is 1 times negative 1. So my final answer is negative 1. So if I had I to the 18th power, it's the same exact thing as saying I have negative 1. Okay, these are the same exact answer, just like 1/2 is the same answer as 8 over 4. Okay, written differently, but saying the same thing. That's essentially what we're doing. What is this? What is this answer equivalent to? Well, it's equivalent to -1. Okay, number 15. When we start getting into negative exponents, remember that is not okay. So exponent rules are still applying in the situation, even though we have imaginary numbers. So if I want to get rid of that negative exponent, remember we just move it to the different part of the fraction, and when we do that, it's going to become positive. But I'm going to do the same exact process, it's just that my I is now in the denominator. So let's think of a number that's divisible by 4 that's under 14. Okay, so 13's not, but 12 is. So I'm going to break this up into I to the 12th times I to the 2nd. Okay, these two numbers right here have to be equivalent to 14, right? 12 plus 2, that's 14. So again, I'm going to break this up into a power of 4. So I'm going to change this to I to the 4th to the 3rd power, right? 4 times 3 is 12. And we know I squared is equivalent to -1. So 1 over, we know I to the 4th is 1, times -1. We know 1 cubed is just 1, times -1. So I get 1 over -1, which simplifies to -1. So I to the -14th power is equivalent to -1, which seems super crazy, but it's true. Okay, lastly, number 6. So again, I have a negative exponent, so I'm going to make this 1 over I to the 21st. Now it's positive. Okay, the next number that's divisible by 4 under 21 is 20. So I'm going to make this I to the 4th to the 5th power, right? 20 divided by 4 is 5, and we're going to leave I. Okay, that's the one with an exponent under 4 that's not going to change. Okay, we're just going to leave that as I. So this is 1 over 1, sorry, I to the 4th is 1 to the 5th power times I, which is equal to 1 over 1 times I, which is just I. Now remember, we can't have I in the denominator, right? That's like having radical -1 in your denominator. So how do we get rid of that? We need to create I squared. So I'm going to multiply the top and the bottom by I. So I get I over I squared. Well, we know I squared is equal to -1. So my final answer is -I. Okay? So I to the -21st is the same thing as saying -I. And I know this is kind of weird. It's going to take a little bit to get used to. Hopefully you have a few days to process this. But again, please feel free to ask any questions on the discussion board as you're working with this. Ask your friends. There's more videos online. Rewatch this if you need to. And then just work as you go.